Hey y'all, welcome back. In this video, we're going to tackle section 3, expression and assignment statements. This video specifically will cover math operators. So we know math operators already, PEMDAS, right? Parentheses, exponent, multiplication, division, addition, subtraction, and yeah, that thing called modulus right there. So modulus might be a little bit new, but we do understand PEMDAS already. So we're going to start with a review of PEMDAS. So first, addition, subtraction, multiplication, division. So here we're going to add 10 plus 7. So the thing about a print line command is it prints whatever's inside, right? And then it goes to the next line. But also what a print line command does is before it prints out, it first evaluates everything inside of the print line command. So it sees a 10, and it sees the addition sign plus a 7. 10 plus 7 is 17. So it does that calculation, it evaluates the expression, and then prints it out 17. Similarly, 10 minus 7 is 3. So it evaluates the expression, and then it prints it out and goes to the next line, so 3. 10 times 7 is 70, and 10 divided by 7 is 1. I don't know about that. 10 divided by 7 is 1. Well, let's give it a try. So we're going to be doing math operators. That's my class name. And for some reason, I wrote 10 divided by 7 is 1. Is that true? Why don't you go ahead and pause the video and try making your own class and plugging it in yourself. When you're done, come back to this video and let's see if we get the same thing. Alright, welcome back. Hopefully you went and tried it yourself. Always good to get that muscle memory into your fingers. System out print line 10 divided by 7. So if I do it on a calculator, I think it's like 1 point something, but apparently it's 1. So I run it, and what do you know? I get a 1. Interesting. All right, so let's continue on. Maybe we can find out why that happens later. But the takeaway is we can perform the same operations we currently or commonly use in math and programming. So the previous slide was integers. We can also do the same thing with decimal values. 10.2 plus 7.3, align vertically, that's 17.5. 10.2 minus 7.3, apparently you get some 2.89995. 10.2 times 7.3, 74.46. 10.2 divided by 7.3, apparently it's this number right here. Interesting. I want to test some of this stuff out. So system.out.println 10.2 minus 7.3. Oh. System.out.println 10.2 divided by 7.3. Let's see. Let's compile. Let's run the main method. Interesting. I wonder if I do my own math, if I'll get the same thing. Let's see. 10.2 minus 7.3. Apparently that's 2.9. 10.2 divided by 7.3. Okay, that one makes more sense. But why is 10.2 minus 7.3 2.9, but it's 2.8995? Interesting. Well, maybe we'll come back to it later. Once again, the takeaway is you can perform the same operations you commonly use in math in programming. So, these were the ones that gave us a little bit of a problem. 10 divided by 7, we both know that's not 1. 10.2 divided by 7.3, I think it rounded a little bit afterwards. So that might be fine. But 10.2 minus 7.3, that's definitely 2.9. Why is it like this? Well, The thing about programming is everything is represented by bits. I'm not going to go too much into it in this slide, but just know that everything is represented in bits, and that's why we might get rounding errors over here. But I'm getting ahead of myself. Let's go to the first one. 10 divided by 7. Why is that 1? Here's a couple of things to remember. An integer in an integer results in an integer. An integer in a decimal results in a decimal. A decimal in a decimal results in a decimal. So I like to think of it as mommy and daddy having a kid. An integer and an integer, they combine and have a kid. What's the kid? It's an integer. Integer and decimal have a kid. What's the kid? Decimal. Decimal and decimal have a kid. The kid's a decimal. Another analogy I like to use is biology. So think of the decimal as the dominant gene in biology. So if you have at all one copy of that dominant gene, then you have that phenotypic trait. Okay, so that's another analogy I found helps my students with this type of thing. Basically, if one operand, if one side of that symbol, the operator, is a decimal, then the result is a decimal. That's the rule of thumb. Okay, so if you actually plug into the calculator, 10 divided by 7 is actually 1.42 whatever. However, 10 is an integer, 7 is an integer. Integer, have a kid, the kid must be an integer. So because an integer with an integer results in an integer, we have to chop off, the correct formal term is truncate. We truncate everything to the right of the decimal point. So that 1.42857142587, we go to that decimal point, chop off everything to the right, and we get a 1. All right, so back to this one. 10.2 minus 7.3 is actually 2.9. But like I said earlier, because of how everything is stored in memory as binary bits, zeros and ones, there can be some margin of error as seen in this output. And that output, the error is called a rounding error. All right, I hope that video helped you understand some of the math operators, PEMDAS. You'll notice that I skipped talking about modulus, right? I have an entire section devoted to modulus, so we'll definitely get some practice. But for now, stay tuned for the next one where we talk about concatenation. See you in the next video.